The y-intercept was 0, and then I need the slope. Tell me another point. 3, 2, perfect. So that means the slope would be up 2 over 3. So what's the slope? 2/3. Perfect. So tell me the equation.
Y equals 2/3 x.
Perfect. I could say plus 0, but I don't have to. Okay. Now for line B, what was the y-intercept? 2. This looks very familiar to me. Does this not look familiar to y'all? Up 1 over 3. Isn't this like one that was on our notes yesterday? So what's the equation? Okay. What is the solution to the system of equations? It's this dot right here, which is 6, 4. I know, same graph. Okay, but let's remember how to check it. So we're going to take the point and plug it in. So in y equals 2/3 x, instead of y, we're going to put 4. Instead of x, we're going to put 6. 2 times 6, 12 divided by 3 is 4. So it works. Okay, then we're going to do the other one. 4 equals 1/3 6 plus 2. What's a third of 6? 2 plus 2, 4. Okay, so now this is the new part. Is each ordered pair a solution to equation A or B, both, or neither? So let's look at 3, 2. How can I know? If it's on both lines, right? So 3, 2 only lands right here. So that would be only A. Okay, 4, 6. 4, 6 is up here. So we would say neither. 3, 3 is only line B. And 6, 4 would be both. And all right, questions from the homework. Yep. Number 4. Okay, did you get a solution of -1, -2?
Yes, but when plugging that back in,
That's where you had trouble?
oh, well, you know what? That would be why I had to myself from the.
Oh, okay.
I was tired, but I was doing this.
But you know what? It's really easy to do. It really, really is to flip them around and everything like that. It really is. Anything else from the homework? No, we're good? Okay, moving on. Today, we're talking about scatter plots. So another new thing. I know it's I think it's probably the first week all year, we've had something brand new every single day. Okay, scatter plots are easy though. Ready? A set of data that involves 2 variables is called bivariate data. That's a fancy $2 word there. Bivariate. The prefix bi means 2, and then variate kind of looks like variable or variant, right? And so there's 2 variables, okay? Bivariate data can be displayed in a scatter plot. A scatter plot shows the relationship between 2 sets of data. The points of real-life data don't always lie on a, what would you say there? On a line, that's right. The data is plotted as ordered pairs on a coordinate plane. Scatter plots are used to investigate a relationship between 2 quantities. Okay, so we're going to graph these points, and then what does the scatter plot show? All right, so first of all, let's set up our graph. We have number of hours driven, number of miles driven. What would be our x? What would be our y?
X is the hours.
X is the hours because,
It's the non-changing variable.
right, it's the non-changing variable. It's the independent variable. So then that means on the y, you should have miles. Okay, I'm looking at our x values. The highest one I see is 5. So that means we can count by what? Ones. Okay. Ooh, on the y values, the highest one I see is what? 250. So I can't count my ones. Give me something else. 50. So let's see. 50, 100, 150, 200, 250. Good job. So let's count my 50s. Okay. And now just take a minute to go ahead and plot all of these points. So 250, we're just going to put a dot. Okay. And then continue. 3, 130, put a dot. And obviously it's going to be, we don't know exactly where 130 is, but we know it's closer to 150 than it is 100. Okay. Okay. All right. So hopefully your graph looks something similar to mine. Before we move on, just tell me something I'm hoping everybody notices about this graph. Sherry, what do you notice?
All the dots lead upward.
Say it again.
There is a positive slope, or like all the dots lead upward.
Oh, so in general, you're saying it appears like it would have a positive slope. Okay. Tell me something else that you notice.
Each number has like two,
And so because of that, it's not a function. That's exactly right. So this would not be a function because we have some of the same inputs giving us two outputs, and that's okay because we're not talking about functions right now. Okay. So we want to know, it says, what does the scatter plot show? So we want to write a relationship here. So what could we say about it? Specifically talking about the data that you see. As what? As the
hours increase.
there you go. As the hours increase, what? The miles increase. Does that make sense?
Yeah.
Yeah, we hope so. If you've ever been on a trip, the longer you're in the car, the further away you're going. Correct? That makes sense. Okay. And so that's what Shrey said a second ago, that in general, it looks like it's going up. If we were to kind of make a line here, it looks like it's going up. All right. So there are 3 types of associations with scatter plots. 3 only. Ready? Positive association. What does that mean? Basically, like the example up here, you know, just put some dots. Something like that. As X increases, what would you say? Y increases. So that would be a positive association. Do you think that's going to be easy for you to remember? Yes, because it looks like it has a positive slope, and we're really good at slope now, okay? So then what do we think a negative association is going to look like? Yeah. Okay, those should all be dots, but in general, is it okay if you think like maybe one's hanging out somewhere? Yeah, but in general, it's going down. As X decreases, Y decreases. And then sometimes there's just no association. What do you think that looks like?
Straight line. Oh, no, no, scatter.
There's no association. The 2 values show no association. Okay? Yes, sir.
Wait, so in the negative association, shouldn't it be as X increases Y decreases?
Is that not what I said? My bad. You're right. Right here. As X increases, thank you. Glad y'all use erasers and pencils. My bad. What we're saying is as X increases, then the Y is getting less. It decreases. That's my fault. I was in a hurry. Okay, so let's just stop. Don't flip the page yet. Let's stop and see if we can come up with any real world examples of a positive association, meaning the more this, the more this. Can you think of one, Samarine?
More hours I work, more money.
Ooh, more hours equals more money, and that's true everywhere except for teaching. Uh-huh.
The longer time goes by, the higher inflation. The higher the prices for everything.
Ooh, the higher we get in years, the higher things cost. That's pretty true. Okay, how about a negative association? Meaning the longer this happens, the less this is happening. Try it. So to me, this one's harder. Easton, what do you think?
The more stuff you have, the less it costs.
The more stuff I have, the less it costs.
So I'll go.
Oh, the more we have of something, the cheaper it is. Okay. Okay, so the higher quantity, the lower the cost. Kind of like going to Costco and Sam's. I'm with you on that. Give me a better one. That one was kind of hard. What do you think? Akshay?
The longer you have a car, the
Yes, the longer, unless it's like a classic, right? But the longer you own a car, the value decreases. How about the longer I burn a candle,
The size decreases.
the shorter it gets? Do you see what I'm saying? Or if I set a cup of water outside, the longer that water sits outside, what?
Yeah.
The less water gets because it's what? Evaporating. Okay? Tell me something that would have just no association.
Shoe size. Like
What do you think?
time and ice cream flavors chosen.
Say it again. So like the longer I've been eating ice cream.
So like whatever time it is in the day,
Oh,
what ice cream is chosen.
oh, I see. Yeah. So at 3 o'clock I choose Rocky Road, and at 2 o'clock I choose vanilla. That has nothing to do with each other, right? Or adult age. Notice I said adult age and shoe sizes.
I mean,
Because once you're an adult, your feet stop growing. Well, unless you have babies and they grow a little bit more. That's okay. But for the most part, and they're not correlated. Like my age has nothing to do with how big my feet are, right?
How big are they?
I work. Anyway. Okay, so you'll get better at this the more you see it, okay? So on the back of that paper, I want you guys to try this with your table. So the first two, you're just saying the relationship. On number 3, you're going to plot it, and I put a note here to make sure you include your labels on the graph. And on the bottom one too, okay? So I think maybe like 5 minutes. What do you think? Pretty easy? We'll see how you are at 5 minutes, okay? Pause the video. Okay, so you should have gotten negative association, positive association at the top. Yes?
Yes.
Okay. On the first graph, did you say negative association, the price decreases as you purchase more boxes of cookies? That's kind of like what Easton said, right? Sometimes the more you buy, the cheaper it is. You guys, did somebody say something different than that? Some of y'all didn't say anything at all except that it was negative. Okay, when it says describe the relationship between the data sets, it's not just looking for positive, negative, it wants some kind of a description. Okay, what about that bottom one? What'd y'all say? No association, meaning age is not related to the number of TVs in your house. Those have nothing to do with each other. No association. Okay? What do you think? Easy or hard? Pretty easy. I agree. Okay? So what I have, if you'll turn your paper over on the back where it was blank, you guys can work the task cards that I put on your desk, and y'all can trade with each other. Guys, the answers are on the back. I'm going to set a timer because we still have like 20 minutes. Okay? And you don't need to do test cards for 20 minutes. So how about we do test cards for about 10 minutes? Then the last 10 minutes, you can work on your homework, which is the last page in the packet. Plus, you also have your test review. So that'll be some time to get some things done. Sound good? Okay.